Good evening. We are looking at the exam review, okay? That is for production and operation management, okay? It is for Mlungwisho University. And the year we are looking at is academic year 2022-2023. And of course, we are looking at question one. Question one is on inventory management, okay? And this question is actually saying the details of a material stocked in a company are given below with the unit cost and the annual consumption in kwacha. Classify the material into ABC, okay, by ABC analysis. Okay, so this is question one. Now, under this question, we are simply saying that item code 501, 502, 503, 504, okay, 505, 506, 507, 508, 509, 510. These are consumption. So we need to multiply by the unit price to get the values. Okay, so after multiplying by the unit price, we are simply getting the figures here. So after getting the figures here, we should rank them starting with the highest one. So the first one is 4,200,000, followed by 2,200,000, followed by 900,000, followed by 550,000, okay, followed by 400,000, followed by 300,000, getting down the list, okay, followed by 80,000, followed by, of course, 25,000, 30,000, okay, and 20,000. So this is how we are now ranking. So 502 is the first one. So C5, 20,000, find the percentage of the total amount. So 4,200,000 divided by the total, we're getting the percentage of 0.48. The cumulative percentage is 0.48 here. Start adding them. This is how you're getting the cumulative percentages. Okay. So from here, these are cumulative percentages. So now we are simply classifying item A goes about 75% of the total inventory amount. Okay, so 25% of the total inventory amount is A. B is about 20% of the total inventory amount. Okay, so our A is ending here. Okay, it's after adding 10% will exceed the 75. So these are A activities. And of course, for B, account for 20% of the total amount. So 20%, at least 20, so meaning you can add these three. Okay, so we can add these three and see that these are item B. And then the rest here account for less than 10%, up to less than 10% of the total amount. So this is the C classification. So this is how question one was all about. Then question two is about inventory management. Okay, so question two is inventory management as well. Okay, so question two is also inventory management. So under this question two, we are saying shopkeeper has a uniform demand of an item, 50 items per month. He buys from a supplier at a cost of 6 kwacha and ordering cost is 10. So if the stock holding costs are 20% of stock value, how frequently should we replenish his stock? So they want us to find our economic order quantity, okay, our EOQ. So for this one, we are now simply saying our demand is 50 items per month times 12 months, okay? Then you're getting 600 items. Unit price is at 6 kwacha. Ordering cost is at 10. So ordering cost is always percentage of unit price. So always percentage, okay, of unit price. All right. So meaning 20% of 6 is 1/4 of 20 ngwe, and getting down to the EOQ, we are simply finding the EOQ as 100 units. So number of orders in a year is 6 times a year. Order 6 times a year to meet annual demand. Order 6 times a year to meet annual demand. Okay, so this is it, what goes on. All right, so that answers the first part of the question. Now here, we are simply saying now the examiners say, suppose the supplier offers a 5% discount orders between 209,999 items and a 10% discount exceeding 1,000. Can a shopkeeper reduce his cost by taking advantage of the discount, 10 marks? Okay, so you need to find the holding cost, 5% now, 5% holding cost, 5% of the pricing. Okay, so meaning 5% of price. Okay, so meaning so the order size will be the discount given is the 5%. Okay, for orders between 200 and 999 and 10% for exceeding 1,000. So let's find the discount. So the discount in this case will be 5% of 6 is 0.3 for this order size. And then for 1,000 or more, it's 10%, which is 0.6. So we're subtracting to find these are unit prices. So holding cost will be 20% of unit price. Okay, so 20% of unit price, 20% of that is 1.14, 1.08. Okay, so this is what we have. So we can now find the total stocking cost or material cost at 1,000, at 100 units. Here, there was no discount for this one. So this one, we didn't have any discount. There was no discount. Okay. And then the total material cost is Q over 2 by C plus D over Q on S plus S times D. So 100 divided by 2 by 1.2. Then here it's 600 over 100 by, this is annual demand, by 10, and 6 kwacha without discount by 600. So we are getting 3,720. Then when you are going to the order size of 200 to 999, EOQ is 102.59. It's not feasible. Okay, so this one does not fall within the range, does not fall, okay, within the range. So what do? We use the 200, use the lower bound, use the Q of 200, okay, units, where the feasibility would have started from. Okay, after using the 200 units, substituting in the total material cost, okay, it is 200 over 2 by 1.14 holding cost from the table. Then substituting here, okay, order size, ordering cost per order is 10. Okay, and then AC is a unit price. Okay, so our unit price is 5.7. So we are simply now getting the total is 3,564. Total material cost is 3,564. Okay. So from here now, we are able to find now the EOQ for 1,000 or more. So it's 105.0. It's not feasible. So use the Q of 1,000 units. Okay. So if you use Q of 1,000 units, you now substitute. Okay, so you now substitute in the formula here. So meaning our total material cost will be equal to Q over 2 by C and plus D over Q on S and plus AC times D. So our total material cost will give us 1,000 over 2, and the holding cost for this kind of order size is 1.08, 1.08 plus 600 over 1,000 multiplied by 10 plus the LC, the unit price in this case. Our unit price for this order size is 5.4. Okay, so 5.4 times the 600. So meaning that our total material cost will give us 1,000 divided by 2 times 1.08. So it's 540. So 540 plus, okay, so 600 divided by 1,000 times 10. It is 6 plus 5.4 times 600. So it's giving us 3,240. And plus a 6 and plus 540. So it's giving us total material cost of 3,786. So you have to compare the costs. So we should order how many units? We should order the 3. Okay, so we should order. Okay, the first one, the first order for 100 units. We have 100 units. We have what? 100 units. We have 3,720. 3,720 for 100. 200 is 3,564. Then 1,000, it is actually 3,786. So here our comment will be, okay, so the comment for this one is that we need to order, comment is that order 200 units, resulting in the smallest, okay, total material cost of 3,564. Okay, so let's put material cost of 3,564. This is it, what goes on this one. All right. So this is it, the end of the question 2. All right, so now getting down to question 3. Question 3 says, information on the production card from the recent engineer shows that end item A composed of 3. So end item A is composed of what? Composed of 3 B's. So B is 3, okay? And the 2 D's, okay? So D is 2. Each B consists of 3 E's and 3 F's. E3, okay? So E3 and, okay, 3 E's and 3 F's. F3. Then each of the C, okay, is composed of 4 B's, okay, so 4 B's, 3 C's, and 2 D's, all right, so from this information here, okay, so The B there is 4, okay, 4 Bs. And of course, each of C has 3 Fs, F3, okay, F3, that is each of C has F3, and okay, F3, and of course, and 4 Gs. Okay, so G4. Then each D has the 3 H, H3, and of course 2I. All right, so each E is composed of okay, 5 I's. So I5, and okay, and so each E is composed of 5I. Okay, so 5I. So we just come once, so 5I. Okay, and each F is made up of 3 J's. So F is made up of 3 J's. Okay, so F is made up of 3 J's and 2 K's. 3 J's, so J3, and 2K. Okay, so 2K. So even this one, you can just reproduce to show the same F made up of J3 and 2K. Okay. So since this is the same I here, we can drop this I from D to come and be at the same level with that other I. Okay. So this is what goes on. So D itself, D is composed of the 2 I's here. All right, so this is the product structure tree. That answers the first question. All right, so we have to now go to the second question. Determine the number of units of each item satisfied. Okay, okay. Determine the number of units of each item required to satisfy demand for a new product for 10. For A is 10 here. So since A is 10, we need to start multiplying. This one will be 10 by 4, 10 by 3, 10 by 2. This one will be 20 by 3, and then 20 by 2. This one will be 30 by 4. This one will be 30 by 3. And then this one will also be 90 by 3. This one will be 120 by 2. Similarly here, we are simply getting the, okay, 40 by 3. And then here, 40 by 3. Then this one will give us 120 by 5. Then here it will give us 120, okay, by 3. Then here it will give us 120 by 2. So these are the workings. Okay, so here now what goes on is that for A, we only have 10. Then for B, we have 40. For C, we are going to say 30. For D, okay, for D, which is only 20. Then for E, we are going to add 120, okay? So we're going to add 120, okay? So it will just be 120 there. For E, it's 120, all right? So E is 120 as for this product. E is 120. Then our F, we need to combine the F's that we have. So there is the F120 plus 90. So F would be 120 plus 90, which will give us the 120 plus 90, giving us 210. Our G is just 30 by 4, okay, because these values are coming from the information given in the question. So G will only be 30 by 4, which is 120, as can be seen from the diagram. So 30 by 4. Okay, so 30 by 4 for G. 30 by 4 is giving us 120. Then for H, our H, it is 20 by 3 because it is a 20 that will come to D, because D came from A, we multiplied by 2. So it's 20 by 3, which is 60. That is for our H. Our H is 60, 20 by 3, which is 60. Okay, our I, we combine the I, 120 by 5 and the 20 by 2. So here we have the 40, and then here is 120 by 5. So 600. Okay, so 600 plus 40 to give us 640 for I, which is the same I. Okay, so J is the last one. So our J is equal to, we combine the J, 120 by 3 and 90 by 3. 120 by 3, coming from F, 120 by 3. Okay, so 120 by 3, that is okay, 360 plus 90 by 3. So it will be 360 then plus, okay, 90 by 3, which is giving us 270. Okay, so 270, so meaning our J will actually be equal to 360 plus 270. The answer is 630. So this is the answers part B of this question. The first part was to draw the product structure tree for this information given in the question. So A item was composed of 4 B's, which is the 4 B's, there are 3 C's and 2 D's, just a recap. And each B consists of 3 E's and 3 F's. And of course, each of C is composed of 3 F's and 4 G's, as can be seen. And D is composed of 3 H and 2 I. Each E is composed of 5 I's. Okay, and each F is made up of 3 J's and 2 K's. 3 J's and 2 K's. So it's the same F here. That's why we had to reproduce from F, this one and this one. We come up with this structure tree for the first one for 10 marks. And then since A are the 10 units, okay, for this to determine the number of units of each item required to satisfy demand for the new order of 10. So A are the 10, so multiplying 10 by whatever quantities that we have here going down the tree. And we have aggregated, if it's the same product, you sum up. So this is answers part B of the question. So this is it. We can now go to question number 4 of this paper. Question number 4 was on forecasting. Okay, so forecasting techniques. And under this one, we are just now looking at calculating the seasonal index. So seasonal index is in forecasting. Okay, so seasonal index is equal to quarter average. If you're using quarter average, okay, over average. Over average, that's how you find the seasonal index. So quarter average over average. Okay, so this is on seasonal index. And then how do we calculate the over average? Over average is simply equal to overall total and divide by total number of measures. So this is how you get the over average, okay? So from here now, we can look at these questions. So this question, we were given the following data relating to the sales Mulongoshi University branded sheets, 1995 through to 1998. These are quarters. So quarter totals, calculate the seasonal index for seasonal or the seasonal factor 10 marks. So we need to find the totals, and after finding the totals, then we're supposed now to find the seasonal indices or indexes. All right, so what goes on here is that we are supposed to find the total. So the totals are here. So the totals for each or adding these ones, we're getting the totals here. Okay, you know about this one. This one is there's nothing here. So the total is 264. Then you divide by how many measures they are there. 264 divided by 4. So this is giving us 66. And of course, the other one is 235 divided by 4, 58.75. Then these ones, we are dividing this by 4, where the 4 is coming from. It's addition of those numbers. By 4, we are getting these ones. So that's the quarter average. All right, so these are averages. So the overall average is equal to overall total. So overall total is 963. The 963 was found by the total was actually equal to 264. So 264 plus 235, then plus the other one is 226, then plus 238. So the total for this one is 963. Okay, 963. So 963 is what we have. Okay. So 963 is what we have. Then we divide by 16 measures. The measures here there were 16, counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So dividing by 16, we are getting 60.1875. So seasonal index is quarter average over average, which is giving us the values here. Quarter average over overall, so 66 divided by 60.1875. Then 58.75 divided by 60.1875. 56.5 divided by 60.1875 and that one. So this is how we're getting the seasonal indexes. All right. So after getting the seasonal indexing for each of these ones, we are now required to answer the second part. Okay, if the shopkeeper estimated his annual total cost for 1999 as 240, all right, determine the seasonalized quarterly forecast for this year. So since we have the total demand of 240, then this 240 we're supposed to divide by 4, meaning that we are getting the 60 there. So this 60 was the forecast for each quarter, and we're supposed to now multiply by the seasonal index so that we get the seasonal forecast for each of these 4 quarters. So this is how this question was supposed to be solved. Okay, so the 60 multiplied by seasonal index, so the seasonal forecast for quarter 1 is 65.4. The other one is 58.8, 56.4, and of course the 59.4 for quarter 4. So this answers the second part of question 4, looking at forecasting to do with the seasonal factors or seasonal indexes. Okay. So this is where the end of this question. This is at the end of this question. All right. So we can end here. So all these 4 questions, they came from different topics. Okay, so the other question 3 was on the MRP, which is material requirement planning. Question 3. Question 2 was on inventory management, the purchasing model, stroke discount model. Then on question 1 was on the ABC analysis, also on inventory. So we end here for now.